Every single year, American lobster farmers raise and process over 12 million pounds of these prized crustaceans, generating nearly $800 million in export revenue alone. But have you ever wondered how these creatures go from tiny larvae floating in specialized tanks to the premium seafood gracing tables across the globe? How do modern aquaculture facilities transform what was once purely a wild-caught industry into a sophisticated farming operation that rivals any agricultural enterprise? Welcome to AgriCraft, where we explore the fascinating intersection of traditional farming and cutting-edge agriculture technology. Today we're diving deep into the remarkable world of high-value lobster farming, from breeding facilities to processing plants, revealing the intricate journey that brings millions of lobsters to international markets. All will be revealed in this video. The American lobster industry represents one of the most dramatic transformations in modern aquaculture history. For centuries, lobsters were considered the poor man's protein, so abundant along the northeastern coast that colonial laws actually prohibited feeding them to prisoners more than 3 times per week. Fast forward to today, and the North American lobster has become one of the most valuable seafood exports in the world, with Maine alone producing over 130 million pounds annually through a combination of wild harvesting and increasingly sophisticated farming operations. What makes lobster farming particularly fascinating is how recent this agricultural revolution truly is. The first successful lobster hatchery wasn't established until the 1870s, and commercial-scale lobster cultivation didn't become viable until the 1980s when advances in water filtration, temperature control, and nutrition finally made it possible to raise these creatures from egg to market size in controlled environments. Today, lobster aquaculture represents a billion-dollar industry that combines traditional fishing knowledge with space-age technology, creating farming operations that look more like underwater laboratories than anything resembling conventional agriculture. The global demand for lobster has exploded over the past 3 decades, driven primarily by expanding international markets in Asia, where lobster consumption has increased by over 400% since 2000. This surge in demand has pushed prices to historic highs, with live lobsters routinely selling for $30 to $40 per pound at wholesale, making them more valuable pound for pound than many cuts of premium beef. American lobster farmers have responded to this opportunity by developing increasingly sophisticated cultivation techniques that can produce consistent, high-quality product year-round, regardless of seasonal variations that affect wild populations. The journey of commercial lobster farming begins in specialized hatchery facilities that operate with the precision of pharmaceutical manufacturing plants. These breeding operations start with carefully selected broodstock, mature female lobsters that can carry anywhere from 8,000 to 100,000 eggs depending on their size. The selection process for these breeding females is incredibly rigorous, focusing on genetic markers that indicate rapid growth rates, disease resistance, and high survival rates in captivity. Premium breeding females can be worth several $1,000s each and are often tracked individually throughout their productive lives using sophisticated database systems that monitor their breeding history, offspring survival rates, and genetic contributions to the overall population. The breeding facilities themselves are marvels of aquaculture engineering, featuring rows of individual tanks where each breeding female is housed separately to prevent cannibalism and ensure optimal breeding conditions. These tanks are connected to elaborate water circulation systems that maintain precise temperature, salinity, and oxygen levels, while continuously filtering waste products and monitoring water chemistry in real time. The water used in these facilities undergoes multiple stages of treatment, including sand filtration, biological filtration, and ultraviolet sterilization to eliminate any pathogens that could threaten the developing eggs or young lobsters. When breeding season arrives, typically in late spring and early summer, the fertilized eggs are carefully harvested from the breeding females and transferred to specialized incubation systems. These incubation units maintain water temperatures within 1 degree of the optimal 20 degrees Celsius, while providing gentle circulation that mimics natural ocean currents. The eggs develop over a period of 10 to 12 months, during which time they're monitored constantly for signs of disease or developmental problems. This extended incubation period is one of the major challenges in lobster farming, requiring year-round climate control and intensive management that makes the operation more complex than most other aquaculture ventures. The hatching process itself is a carefully orchestrated event that can take several weeks as eggs mature at slightly different rates. Newly hatched lobster larvae are microscopic, translucent creatures that bear little resemblance to adult lobsters. These larvae must immediately be transferred to specialized nursery tanks where they'll spend the next 4 to 6 weeks floating freely in the water column, feeding on carefully prepared diets of microscopic organisms including brine shrimp, rotifers, and specially formulated commercial feeds that provide the precise nutritional balance required for proper development. The nursery stage represents one of the most critical periods in lobster cultivation, as survival rates during this phase often determine the overall success of the entire farming operation. The larvae are incredibly sensitive to water quality fluctuations, temperature variations, and food availability. Advanced lobster farms employ teams of marine biologists and aquaculture specialists who monitor these nursery systems around the clock, adjusting feeding schedules, water flow rates, and environmental conditions based on the behavior and development of the larvae. Automated feeding systems deliver precisely measured quantities of food at regular intervals, while computer-controlled monitoring systems track water chemistry parameters and alert technicians to any deviations from optimal conditions. As the larvae develop through their various molting stages, they gradually begin to resemble miniature lobsters and start exhibiting bottom-dwelling behavior. This transition marks their readiness for transfer to juvenile growing systems, typically occurring when they reach about 1 inch in length. The juvenile growing phase takes place in specially designed tanks with complex 3-dimensional habitat structures that provide hiding places and territorial boundaries, reducing aggressive interactions that could lead to injury or death. These growing systems often incorporate advanced biological filtration using beneficial bacteria colonies that convert waste products into harmless compounds, maintaining water quality in densely stocked environments. The feeding program during the juvenile phase becomes increasingly sophisticated, incorporating a variety of protein sources including fish meal, crustacean meal, and plant-based proteins that promote rapid growth while maintaining optimal shell development and meat quality. Many operations now utilize computer-controlled feeding systems that can deliver different food types at various times throughout the day, mimicking the varied diet these creatures would encounter in the wild while ensuring consistent nutrition delivery across thousands of individual animals. Temperature management during this growing phase is absolutely critical, as lobsters are cold water creatures that require precise thermal conditions for optimal growth. Most commercial operations maintain water temperatures between 15 and 18 degrees Celsius year-round, using sophisticated chilling systems that can cost hundreds of thousands of dollars to install and operate. These cooling systems often incorporate heat recovery technology that captures waste heat for use in other facility operations, improving overall energy efficiency in what is inherently an energy-intensive farming process. The growing phase typically lasts 18 to 24 months, during which time the juvenile lobsters will molt numerous times, shedding their shells as they grow larger. Each molting event represents a vulnerable period when the lobsters are soft and defenseless, requiring careful monitoring and sometimes individual isolation to prevent cannibalism. Advanced facilities use automated grading systems that sort lobsters by size after each major growth period, ensuring that similarly sized animals are housed together to reduce aggressive interactions and optimize feeding efficiency. As the lobsters approach market size, typically reaching 1 to 2 pounds, they enter the final conditioning phase where they're prepared for harvest and processing. This phase focuses on maximizing meat quality and shell hardness while reducing stress levels that could affect the final product quality. The conditioning tanks are designed to simulate optimal natural conditions, with carefully controlled water flow, lighting cycles, and feeding schedules that promote the development of firm, sweet meat that commands premium prices in international markets. The harvesting process itself is a carefully timed operation that must balance animal welfare concerns with processing efficiency. Unlike many other forms of aquaculture where harvest can be delayed if market conditions aren't favorable, lobster harvesting must occur when the animals reach optimal size and condition, regardless of market fluctuations. The harvest typically begins with draining the growing tanks and carefully collecting the lobsters using specialized nets and handling equipment designed to minimize stress and physical damage. Once harvested, the lobsters are immediately transferred to holding systems where they can be kept alive for extended periods while awaiting processing or shipment. These holding facilities maintain near-perfect water conditions and can accommodate thousands of pounds of live lobsters, allowing farms to coordinate harvest timing with processing schedules and market demand. The holding systems are typically equipped with backup power supplies and redundant water circulation systems to ensure that valuable inventory is protected even during equipment failures or power outages. The processing phase of lobster farming represents a fascinating blend of traditional seafood handling techniques and modern food processing technology. Most large-scale lobster farms operate their own processing plants or work closely with specialized seafood processing facilities that can handle the unique requirements of live lobster processing. These processing plants are designed to maintain the highest standards of food safety and quality while efficiently handling large volumes of live product. The processing operation begins with careful grading and sorting, using both automated systems and experienced human inspectors to categorize lobsters by size, quality, and market destination. Premium-grade lobsters destined for high-end restaurants and export markets are handled with extraordinary care, while lower-grade animals may be processed for different market segments or value-added products. This grading process is critical for maximizing the economic return from each harvest, as price differentials between grades can be substantial. The actual processing steps vary significantly depending on the final product format, but most operations begin with thorough cleaning and inspection procedures that remove any debris or damaged shells while ensuring that only healthy, high-quality animals proceed to the next processing stages. Advanced processing plants utilize conveyor belt systems and automated handling equipment that can process thousands of lobsters per hour while maintaining consistent quality standards and minimizing labor costs. For lobsters destined for live shipment, the processing focus is on packaging and logistics systems that can maintain animal health during extended transportation periods. This involves sophisticated packaging systems using specially designed containers that provide optimal water circulation, temperature control, and waste management during shipment. These shipping containers often incorporate battery-powered circulation systems and gel-based cooling systems that can maintain optimal conditions for up to 72 hours without external power sources. Live lobster packaging operations utilize automated systems that can rapidly sort, weigh, and package individual lobsters while maintaining strict hygiene standards and temperature control throughout the process. The packaging materials themselves are specially designed to provide optimal gas exchange while preventing escape and injury during handling and transport. Many operations now use biodegradable packaging materials that reduce environmental impact while maintaining the performance characteristics required for successful live seafood shipping. For processed lobster products, the operations become even more complex, involving cooking systems, meat extraction equipment, and specialized packaging lines that can produce everything from whole-cooked lobsters to individual tail portions and extracted lobster meat. These processing lines incorporate multiple quality inspection points where trained inspectors examine products for defects, proper cooking, and packaging integrity. Advanced facilities utilize metal detection systems and automated weight verification to ensure that finished products meet exact specifications and food safety requirements. The cooking systems used in lobster processing represent sophisticated pieces of industrial equipment that can precisely control temperature, cooking time, and steam circulation to ensure consistent product quality across large production runs. These systems often incorporate computer-controlled recipe management that automatically adjusts cooking parameters based on product size and type, ensuring that each batch receives optimal treatment for maximum quality and yield. Temperature control throughout the processing operation is absolutely critical, with strict protocols governing the time and temperature exposure at each processing stage. Most facilities utilize continuous temperature monitoring systems with automatic recording and alarm capabilities that ensure compliance with food safety regulations while maintaining optimal product quality. The processing environment itself is typically maintained at carefully controlled temperatures and humidity levels to prevent bacterial growth and ensure worker comfort during intensive processing operations. Quality inspection during processing involves multiple checkpoints where trained personnel examine products for visual defects, proper cooking, accurate weights, and packaging integrity. These inspection procedures are often supplemented by laboratory testing programs that verify microbiological safety, chemical composition, and nutritional content of finished products. Advanced facilities utilize automated vision systems that can detect defects and inconsistencies that might be missed by human inspectors, ensuring that only premium quality products reach the market. The packaging phase of lobster processing utilizes highly automated systems that can rapidly package products while maintaining strict hygiene and quality standards. These packaging lines often incorporate modified atmosphere packaging technology that extends shelf life by replacing air in packages with carefully balanced gas mixtures that inhibit bacterial growth and maintain product freshness. The packaging materials themselves are carefully selected for their barrier properties, ensuring that products maintain optimal quality throughout their shelf life while providing attractive presentation for retail and food service customers. Labeling systems in modern lobster processing facilities are fully automated and integrate with inventory management systems to ensure accurate product identification and traceability throughout the supply chain. These systems can print and apply labels with product-specific information, including harvest dates, processing dates, nutritional information, and handling instructions while maintaining production line speeds that can exceed several thousand packages per hour. The distribution phase begins with sophisticated cold storage systems that can maintain precise temperature control, while accommodating the varying storage requirements of different product types. These storage facilities often utilize automated inventory management systems that track product movement from processing through shipment while maintaining strict first-in, first-out rotation protocols that ensure optimal product freshness. Transportation of processed lobster products requires specialized logistics systems that can maintain precise temperature control throughout the supply chain while providing real-time tracking and monitoring capabilities. Many large-scale lobster farming operations work with dedicated seafood logistics companies that specialize in temperature-controlled transportation and have established networks for rapid distribution to both domestic and international markets. The shipping containers used for lobster distribution incorporate sophisticated monitoring systems that continuously track temperature, humidity, and location throughout the transportation process. These systems can provide real-time alerts if conditions deviate from specified parameters and maintain detailed records that can be used for quality assurance and regulatory compliance purposes. Advanced shipping operations utilize predictive analytics to optimize routing and timing, ensuring that products reach their destinations in optimal condition while minimizing transportation costs. International distribution of lobster products involves additional complexity related to customs clearance, documentation requirements, and varying food safety regulations in different countries. Many lobster farming operations employ specialized export managers who coordinate these international shipments while ensuring compliance with all relevant regulations and maintaining the cold chain integrity required for premium seafood products. The byproducts generated during lobster processing represent significant additional revenue opportunities that modern farming operations have learned to exploit effectively. Lobster shells, which are rich in chitin and calcium compounds, are processed into various industrial products including biodegradable plastics, pharmaceutical ingredients, and agricultural soil amendments. These byproduct processing operations often utilize specialized grinding and chemical extraction equipment that can recover valuable compounds while minimizing waste disposal costs. The processing wastewater generated during lobster operations undergoes extensive treatment using biological treatment systems that remove organic compounds and nutrients while producing clean water that can be safely discharged or reused. In facility operations, many advanced facilities incorporate water recycling systems that can recover and reuse up to 90% of their processed water, reducing both environmental impact and operating costs. From a culinary perspective, farm-raised lobsters have achieved remarkable success in premium restaurant markets worldwide, with many chefs praising their consistent quality and availability compared to wild-caught alternatives that can vary significantly in quality and seasonal availability. The controlled growing conditions used in modern lobster farming operations produce meat that is consistently sweet and tender, while maintaining the firm texture that characterizes premium lobster products. The nutritional profile of farm-raised lobsters closely matches that of their wild-caught counterparts, providing high-quality protein with low fat content and significant amounts of essential minerals including selenium, zinc, and phosphorus. The controlled diet used in farming operations can actually enhance certain nutritional characteristics while eliminating the potential for contamination from environmental pollutants that sometimes affect wild populations. The environmental impact of modern lobster farming represents a significant improvement over traditional fishing methods, with aquaculture operations typically producing much lower carbon footprints per pound of protein produced compared to fishing vessels that must travel long distances and burn significant amounts of fuel to harvest wild populations. Advanced lobster farms incorporate numerous sustainability measures including renewable energy systems, water recycling technology, and integrated waste management systems that minimize environmental impact while maintaining high production efficiency. Many lobster farming operations now participate in third-party certification programs that verify their environmental and social responsibility practices, providing consumers and buyers with assurance that their products are produced using sustainable methods. These certification programs typically require comprehensive auditing of farming practices, environmental impact assessments, and worker safety programs that go beyond basic regulatory requirements. The economics of modern lobster farming demonstrate the remarkable transformation of this industry from a traditional fishing activity to a sophisticated agricultural enterprise. Large-scale operations can achieve production costs that are competitive with wild-caught lobsters while providing superior consistency and availability that command premium prices in discerning markets. The capital investment required for modern lobster farming facilities can exceed $10 million for large-scale operations, but the potential returns justify these investments when managed properly. The technology integration in modern lobster farming continues to evolve rapidly, with many operations now incorporating artificial intelligence systems that can optimize feeding schedules, predict optimal harvest timing, and monitor animal health using computer vision systems that can detect subtle changes in behavior or appearance that might indicate health problems. These technological advances are making lobster farming increasingly efficient while improving animal welfare and product quality. The workforce requirements for modern lobster farming operations combine traditional aquaculture knowledge with high-tech skills including computer systems management, water chemistry analysis, and automated equipment operation. Many facilities employ teams of marine biologists, aquaculture technicians, and processing specialists who work together to maintain optimal growing conditions while maximizing production efficiency and product quality. Looking at the complete journey from breeding facility to international distribution, modern lobster farming represents one of the most sophisticated forms of aquaculture practiced today. The transformation of tiny larvae into premium seafood products ready for export to markets around the world requires the coordination of complex biological, technological, and logistical systems that rival any manufacturing operation in their precision and efficiency. The success of American lobster farming in international markets demonstrates the potential for high-value aquaculture to compete effectively in global food systems, while providing economic opportunities in rural coastal communities. As consumer demand for premium seafood continues to grow worldwide, particularly in emerging markets where disposable income is increasing rapidly, the future of lobster farming appears exceptionally bright. This remarkable industry showcases how traditional fishing communities have successfully adapted to changing market conditions by embracing advanced technology and sophisticated management practices. From the carefully controlled breeding facilities, where the journey begins, to the automated processing plants where millions of pounds of premium seafood are prepared for global distribution, every step in the process reflects the evolution of American agriculture toward increasingly technical and specialized production systems. The modern lobster farming industry proves that with proper application of science, technology, and business management, even the most challenging agricultural enterprises can achieve remarkable success while contributing to food security and economic development in rural communities across America. Thank you for joining us on AgriCraft for this deep dive into the fascinating world of high-value lobster farming. If you found this exploration of modern aquaculture technology interesting, please give this video a like and subscribe to our channel for more insights into American agriculture and food processing technology. We'd love to hear your thoughts about lobster farming in the comments below. And don't forget to hit the notification bell so you never miss our latest agricultural documentaries exploring the incredible innovation happening in farms and processing facilities across the country.